Hello fellows, welcome to my channel Hi Study. Today I'm going to start my first video by introducing the structure of benzene. Before that, let's talk about the classification of organic compounds. Benzene has a hexagonal and planar molecule with the formula of C6H6. And if we now talk about the hybridization of the carbon atoms in benzene, it is sp2 hybridized. We could see when a carbon atom is excited, what happens? The electron in the 2s2 orbital goes to 2pz. And now we could see that from 3 hybrid orbitals, 2 hybrid orbital will overlap with the neighboring carbon atom and other orbital will overlap with the hydrogen's orbital. And because of this overlap of p orbital, it produces a ring of delocalized electron above and below the plane of benzene's carbon atom, and this causes a pi bonding in the benzene. We have 6 delocalized electrons around the ring. Because of the delocalization, the structure of benzene is relatively stable. When we study benzene, we will learn about two structures of benzene. There at the top of the page there are two structures, but we use the second structure the most because the first structure is Kekulé structure, where Kekulé have some unexplained properties. The first property is, since the structure has 3 double bond, it would act like alkene and should undergo addition reaction, but benzene rarely undergo addition reaction. In my next video, I will talk about the reactions of benzene. Benzene is a symmetrical molecule, but Kekulé's double bond and single bond structure would distort the hexagonal shape. Also, the CC double bond has a length of 0.134 nanometer and CC single bond has a length of 0.154 nanometer, but the carbon-carbon bond in benzene has a length of 0.139 nanometer. And the bond angle of carbon is 120 degree. This shows that the structure that Kekulé had introduced was little different from the actual structure of benzene. So we use the actual structure of benzene, which is the second structure at the top of my page. Now let's talk about arenes. What are arenes? Hydrocarbons. We all know about hydrocarbons. Hydrocarbons that contain at least one benzene rings are called arenes. And arenes have different properties, like arene have a higher molecule melting point and a boiling point than aliphatic hydrocarbons. Why? Because of delocalized electron. The delocalized electron in arene can form temporary dipoles, so have strong van der Waals force. Benzene is non-polar molecule, but arenes are polar. Because of the side chains, they have permanent dipole between them. Now let's talk about some compounds here. Let's see. The first compound is a chlorobenzene because we have benzene and one chlorine, and the second structure is a nitrobenzene. Let's skip the third structure and let's go to the fourth structure. Here what we can see that there I have numbered the carbons 1, 2, 3, 4, 5 and 6. When bromines are attached to the carbon, bonded to the carbon, what can we see? It is bonded with the second carbon, fourth carbon and the sixth carbon. So we could name this 2,4,6 tribromobenzene. Now let's go to the third structure. We know OH is the functional group of alcohol. However, when this kind of structure we see, this is not an alcohol functional group of alcohol, but this structure is known as phenol. This is a special structure and we will talk about phenols in my future videos. Now, linking structure 3 with the last structure I have drawn, we could see a phenol and which is bonded with bromines, and we could name this 2,4,6 tribromophenol. Thank you for watching the video, and please don't forget to subscribe my channel.